So data cleaning, we discussed about what is data clean. So initially, while you are implementing the pipeline of any ML model or AI model, initially the first step is data clean, right? So you are asking in the question and answer that, sir, can you explain me about the pipeline of that is pipeline is nothing but the workflow when we create an AI model or a ML model. So Python is a language, or R also. We can use the R language also. We can use MATLAB is one more tool mostly used. R, Python, or MATLAB, or few more languages are there using which we can implement this implementing the AI or ML model. We are most of us we are learning the Python, but in US or some countries, most of the projects, not most, they're also working on the R2. So along with this Python programming, teaching you Python programming, we are going to teach in from this week only. The separate classes will be held for the R also, R tools. R tool, I hope all of you know R Studio or R tool, which is used for the this data analysis. So that we are also going to give you in link. Who are free and want to learn, you can also learn this R tool also. Right. So before explaining all these things, data cleaning, what is data cleaning? Let me show you a few example of. Let me show you another PPT which shows the pipeline. Okay, one. So first of all, in terms of the pipeline, A or ML pipeline, what we call a pipeline. A or ML pipeline. When you even an interviewer or a client may ask you what are the AML pipelines you have worked. So it is nothing but a structured workflow for building AML solutions. Okay, it's a structured workflow. So which ensures the repeatability, scalability, and reliability. That means whenever you want to go back for one step, you can go back. That we call as repeatability. Whenever you want to enhance, you can enhance. That we call as scalability, or we can decrease it. That we call as scalability. And reliability means how we can depend. The model can depend on this structure. This pipeline is a structured workflow for building AI and ML solutions. What are the stages? The basic stage is after the requirement analysis, the plan for AML design, and plan includes always input, output, and what are the different stages, what we'll do. So that is the plan. Initially, the solution design for a pipeline has to be done. That we call as an artifact. Remember that word, artifacts. So artifacts are the solution designs using which we will generate the start doing the work. Okay, so first we'll prepare a solution after the requirement analysis. Then, Divya, are you recording the session?
Yes, sir. It is recording.
Yeah. So after planning requirement analysis and concluding the requirement, concluding for the first phase as well as it can be enhanced afterward as we are going through the agile models. Then after that, designing the solutions and after preparing the artifacts and documents, user stories and everything, then we'll go for the implementation. In this implementation, we'll first start with the stage called data collection. So data collection is collecting the data which are required for the generating the ML model. It may be the mostly we will try to get as much data as possible. Okay, so and which is relevant to the output, creating the AR ML model. If it is not relevant to AML model and we are adding it to the in the design, then obviously we'll face the problem. The second category is data clean. The second stage is with what we are talking about, data cleaning and pre-processing. After collecting the data, or generating the pipelines. See, data collection means sometimes we may work on the real-time data. Sometimes we may work on the previous data. When we are working on the existing data, previous data, all the collection will be done. Or if you are working on the stream of data, then and every time model is being updated. In that case, will generate a pipelines where data pooling is done into the data pool. Okay, a data lake, or we call data lake. This is the general as a fresher. If you're a fresher, you please remember these words: data lake, data warehousing, and everything. They're combining into the big data. Every concept they're combining into the data lake. Though there are differences, industry uses nowadays using the data lakes. So then after doing establishing the pipeline based on the requirement or collecting the data, the next phase is data cleaning and pre-processing. So that's what we are discussing. Data cleaning refers to different models, right? As we discussed. What are those? It is the main foundation of the pipeline, which removes the missing values, handles the missing data, removes the duplicates. So missing values, how we can then how it can do? We can do using the imputation or removal. There are two, right? Two strategies we have discussed in the yesterday's class. One method is removal, another method is imputation. So in the data cleaning, removing of the duplicates, handling the missing data. Next, we are going to discuss correcting the inconsistencies. Okay, then reducing the noises, sensor or medical data, what are the applications we're discussing. Then outlier detection, then standardization and normalization. All these are the different cleaning stages or different steps in the cleaning stage. So we have practically worked on removing the duplicate, handling the missing data.
Honey, tell
Now we are
everybody to. Honey, 1 minute.
yeah. Divya, are you talking in my class? Okay.
No, sir. No, sir. Sorry for interruption. No, sir.
Noise reduction and outlier detection and standardization and normalization. These are the steps which we are going to discuss further. So these are the main stages. So first one is the data collection, then data cleaning and pre-processing. That means making the ready data so that we can directly give that to model, AI model or a ML model for which we are applying. Then model feature engineering. Feature engineering is the step where we will generate or adjust the features or select a few features when more features are there. So that we call as feature engineering. We may combine some features or update some features, or by little updations the whatever attributes we have based on that, or we may have complex of attributes. Like one image may have thousands of attributes, but we need only few, right? Or some data may have thousands of attributes. That only selecting the features which are required by our AL ML model, and using them or combining that we call as a feature engineer, right? So after selecting the required columns, like we are taking the uh, employee or we're talking about the health records, right? Say we are considering we are creating a AR ML model that after certain age, is this patient can get any cancer? Are there any chances of getting the cancer? That is very important, right? Cancer is always curable if it is recognized in early stages. If cancer is uh, recognized after such certain stages, then it is very critical for the patient to survive, or he may be deceased in few months or few years. So it is always curable. So always there is a need of the prediction of the cancer. If our model wants to, we need to create a AI model or a ML model which will predict the chance of the getting the cancer for a particular user. In that case, what we will do, we will select the features which are required for generating the model which is relevant to the cancer. So what is the output? Chance of getting the cancer or no chance of getting the cancer. For that, what are the features required? Right? So age is also required. Previous any scenarios or attributes may be required. But his name is not required. His name is not, by name, nothing happens. Right? So any unwanted features can be eliminated or any required features can be combined. So that we call as feature engineering. Right? So in the example I said, whenever we are creating A or ML pipeline, the feature engineering is also important. That's the next stage after the data cleaning. Then training the model. When we want to create a AL ML model, that model, prediction model, we need to train using the data which we clean. We applied the feature engineering, which we collected all this data, which has processed by these steps, is given to the training. Then once a model, a prediction model is designed, right? So after giving the data to the AI models, prediction model, then that model will be trained to or analyze. That model is trained based on the data, so that it can predict whenever next data comes, right? Real data comes. So this training is the fourth step. Then evaluation of the model is another step. So, okay, we developed it model. We collected the data, we applied the cleaning, we applied the feature engineering, we trained a model, A or ML model or prediction model, which tells next time data comes that this patient may get the cancer or may not get the cancer. But how do we know that this model is correct or working well? For that scenario, what we have to do? We have to evaluate the model. So normally what happens? They'll separate the data into training data and testing data, and they'll apply to the trained model, they'll apply this test data, and using the text data, they will check whether how much accurately this model is working. Any model will not work 100% correctly. Will if it is if it is above threshold value. So say our model, we declare that if it is if the test is passed above 90%, we consider this as a good model. Then we'll consider. Otherwise, if the evaluation says that only 70% results are correct, 30% results are wrong, then what we'll do, if it is below our threshold value, we'll go back and regenerate the model, recheck the features. Okay. So once evaluation is okay and model is correct, then we'll go for the deployment. And we'll parallel deployment means in the application we are using, where the backend code has to be kept, front-end code has to get, how the inputs can be applied, what is the cloud structure. So how we can make it live, how we can, are we working in the API model, or we are working on the direct model, how we are doing that, or we are using the microservices, then in which servers we have to keep it, what is must be the speed, what is must be latency, what must be the how we secure the system. All this comes under the deployment. So then the other thing is monitoring and feedback. So these are the 7 stages. What we call 7 stages of AML pipeline. So you must go, we have to do all these things to become a engineer or an ML engineer, right? So there are a lot of difference between the AI engineer and ML pipelines, but basic steps are common. So we'll discuss further when we learn when we complete the first stage and second stage, then we'll go expertise the learning, right? In those cases, we'll learn, if you're AI engineer, if you want to go in channel of AI engineer, then you will be trained specifically on the AI models. If you want to go in the ML models, then it will be trained in the ML model. So for now, these are the common steps, stages which we require for building an AI or ML solution, right? So we are talking about the data cleaning, right? So previous classes also we discussed about the data cleaning. So what are the this this is data cleaning is a foundation of the pipeline. You can see this is the first step of the not first, second step. But most of the time, data, once we got the data, obviously we'll work on the clean. So that's why we call it as the foundation of the pipeline. Then in this, as we discussed in the previous sessions, we'll remove the duplicates, handle the missing data, correct the inconsistency and noise, and we'll do the noise reduction, and we try for outlier detection, and we'll try to solve that problem, and we'll standardize or normalize the data. These are the different steps in the data clean. So in robotics or a health examples, we'll see why we need to do the data clean. Normally, the sensor fusion requires clean and aligned data. Okay, so that is a major problem. And by using LiDAR or LiDAR visualize data or cameras data, we by using the data cleaning, we will remove the false signal. And when we are getting the GPS or sensors reading, we'll handle the mostly will get the chances of getting the missing data. Or all this data cleaning will help us to get the accurate navigation and safe decisions. Okay, look, right? So LiDAR false signals mostly will get by the uh, reflection errors and all. We discussed in the previous session also. And in healthcare, normally, what is EHR? EHR is the word. Just remember, electronic health records may have typos, missing values, and duplicates. EHR is the common word in the healthcare projects. Okay, please remember that while these words. And because of the typos or missing values or duplicates, EHRs must be cleaned before going into the generating the ML model. And just cleaning data is equal to accurate diagnosis and patient safety. Okay, and it prevents the bias in the prediction models, right? It ensures the regulatory compliance, like regulatory compliances means, right? HIPAA, GDPR, these are compliances which tells that we must protect the user data while we are working on the different projects. So these are very important all over if you're working on the health data. GDPR and HIPAA are the policies which you have to maintain by encoding and decoding the user data. So how we encode the personal information never can be released. Say some Raju is having some disease with some attributes. This information cannot be leaked. So what they'll do, they will encrypt the data, encode the data. They'll give, instead of name, they'll give some codings. Instead of address or a phone number, they'll use some codings. And that coded data only is used in the analysis. Okay, when analysis done, again that will be decoded, right? So that mapping and coding is done in the to maintain the regulatory compliances like HIPAA or GDPR. Okay, so these are the, you can Google them. What is HIPAA or GDPR? So you can get that is highly mandatory to maintain. Okay, so coming to the different libraries or tools which we use for AI or ML pipeline. So here for data collection, normally we collect using the SQL, APIs, ROS, okay, robotic operating systems and requests based using these will collect the data. Normally, healthcare data will get from the EHR and electronic health records and tests, right? And normally there are plenty of census data also in the healthcare. So sensor data nowadays, sensor data, apps data, lab tests, EHR, normally they'll maintain a master data for storing all the data collected from the different sources. These will sources data will be kept in the data pool. Okay, data pool of the hospital or any medical system medical system or anywhere. So this data, mostly there are plenty of different sources of the data will be there. And whenever this data is collected, as I said, all the compliances are maintained, right? So, so this LiDAR, then coming to the robotics. This robotics data, mostly we call them as robotics. Normally, we mostly we work with the. There are other categories of data also, but nowadays most of the work is image. See, robo has to move, then it has to analyze the environment, right? So for that, LiDAR, light detection and ranging sensor will be there. LiDAR, please remember, LiDAR is a sensor, crucial sensor in robotics that provides the real-time high-resolution 2D or 3D mapping of an environment using pulsed laser light. Okay, so LiDAR is a crucial sensor. LiDAR means light detection and ranging. LiDAR means light detection and ranging. So this sensor provides a real-time and high-resolution 2D or 3D mapping of all environment using pulse light. So it, by measuring the time it takes for a laser beam to reflect off an object, and a LiDAR sensor can create a dense collection of data points known as point cloud. Okay, known as point of cloud to represent the surrounding world. Whenever robo is trying to move, to represent the surrounding world, this light detection and ranging LiDAR is used. This is the sensor. It gets the data by provide sense using the laser light and getting the reflex, and this data is collected in terms of the data points are collected in terms of the point clouds. Okay, please remember. So this uses LiDAR uses critical task like SLAM is a word in the robotics that we call as simultaneous localization and mapping. Okay, so LiDAR sensors are central to the SLAM algorithms, which allow robot to create a map of its surroundings while simultaneously tracking its own position within the map. So when you're standing somewhere, normally what you do, you observe the surrounding, how based on the surroundings only, whether how you stand or how you move, how you do that, you'll plan, right? In the same manner, this simultaneous localization and mapping, SLAM, is uses this LiDAR sensors. Okay, this SLAM algorithms uses this LiDAR sensors, which allows the robot to create a map of its surroundings, right? So this data will get, this LiDAR data will get, GPS data we get, cameras data we get. Okay, other the position of the robo arm, the position of motors, the position of the heat in the body, and the angle of arm. Okay, the force it is applying. All these are the different sensors data which will get from the robotics or which will be collected in terms of the robotics. All this data has to be analyzed. For that, these are the different sources. For collecting the data, these are the different sources. In terms of the healthcare, EHR lab tests are main. And for in case of robotics, LiDAR data and GPS data and cameras are very much of use. So this data collection can be cleansed. Okay, use in if you're using the Python, we can clean it using the pandas, NumPy, and SciPy. Okay, so these are the tools you have to learn in this stage. First, in the data collection, you have to learn Kafka. Or if you're using stream of the data, you have to learn the Kafka and different cloud technologies or any technologies which are used to get the data, SQL or APIs or RBAs or requests. Any tools you need to learn to collect this data and make it worthable, available for us for our generating the model. The second category is second stage is data cleaning, right? Here you need to learn the pandas, NumPy, and SciPy. Okay. So what we'll do, we already know in the data cleaning, what we'll do, we'll work on the duplicates, we work on the missing data, we work on the noise, we work on the outliers, we work on the inconsistencies. All this work we do using the data cleaning. For that, we use the pandas, NumPy, and some SciPy, right? Then the third stage, we call it as feature engineering. So in the feature engineering, as I said, we'll require the features only. Okay, like for healthcare, BMS and blood pressure features we use for uh, generating the uh, BP or to check for heart on a bit, right? So here for these feature engineering, selecting the appropriate, selecting and combining or deleting or updating the features, we use the pandas and sklearn or OpenCV. These are the basic libraries which we use for the feature engineering. So data cleaning, we work mostly using the pandas, NumPy, SciPy, and even scikit-learn for graphically matplotlib or any plotting or a graphical libraries for graphically recognizing the outliers and all. Basic one are these pandas, NumPy, and SciPy are the basic one are these. Then feature engineering, pandas are sklearn and OpenCV, and these are the basic for engineering the columns of data. Then for model training, we use training the model, whatever model we are using. Then we go for learning the scikit-learn or TensorFlow or PyTorch, right? So here, this scikit-learn, TensorFlow or PyTorch mostly will work. There are other libraries also, but these are the basic and common things to train a AI model or a ML model based on the data collected and processed and feature engineering is done. Based on this, when we want to train, we can use this scikit-learn or a TensorFlow or PyTorch. There are others also, we'll discuss further. So in the healthcare, we will mostly use in the disease prediction as we discussed, or in the robotics, we use the reinforcement learning, right? Then for evaluation of the generated designed model, that is for testing and checking the correctness of the model, we use the sklearn.metrics or matplotlib or the basic common libraries which are used over here. Okay, so these things you must be good for evaluation. First, you need to know what are the metrics which are to be used. Then you have to learn this how we can implement that, calculate those metrics, which algorithm uses which metrics, all those things. Then the sixth one is the deployment. For learning the deployment, you have to learn class, fast API, ROS, or Docker. Okay, these are the Docker, Kubernetes, or AWS services. You should learn basic deployments services, and Flask is the framework, right? And fast API is also again a library and framework which we can implement the APIs. And robotic operating system and Docker, all these are the basic things you have to learn or need not to learn, but you should know what will happen out there, right? Uh, but if you know well Flask, that will be good. And Docker is also pretty much important. And Fast API also, how the security or authorizations will run, and how two-way communication happens, how security is maintained, encryption is done. These at least those basic things you should know in the deployment. That we'll also try to teach you. Up to evaluation will teach very good, but Flask also will teach, and Fast API and ROS and Docker a little bit out of the syllabus. But if you learn those things, that will be good for you. Then the other one is monitoring. For that, we can use the MLflow and Kubeflow and Grafana, which are used for monitoring and feedback of this deployed systems, how they are working. So this is the pipeline. You should do at least one pipeline, one project, at least one pipeline you have to do. Implementing real-time scenarios. A real-time deployment has to be done. It should work. Everyone has to do those things. So I'll tell you, after 1 month, you please create your own AWS accounts so that you can complete this pipeline. Okay, they are free. You need not to pay for AWS. They'll give you some, they'll charge from 2 rupees or something, AWS people. You need not to pay, and you practice. Immediately you have to stop. If you are creating a, what we call in AWS bucket you have created, immediately you should stop it. Otherwise, what happens, it will be charged. If you're creating a node, immediately you should stop it after practicing. If you're using some other service, you need to check whether it is free trial or a paid service. Better to avoid the paid service. If it is asked, AWS is asking you for 10 rupees or 50 rupees for in the test mode, then that is okay, right? So like that, after 1 month, you please you start, be ready with the AWS accounts. Why I'm saying 1 month means, or now also you can create AWS accounts, so that when we complete the pipeline, see, data cleaning we are completing, then we'll go for feature engineering, then we go for the model training. Before the model training, we'll teach you what are the AI and ML algorithms which are used for what, which for which application we'll use for AI application, which for which we use the ML application. Then we'll go for the evaluation. Then we'll go for the deployment. So this deployment also you should learn. So because you should at least you will be having a confidence that I have done one pipeline, right? So that will make you a better trainee, right? So then we'll see that. So outerly, this is the pipeline with libraries and tools. Okay, so please take the photo of this. Anyway, these recordings will be there. This pipeline with libraries and tools, you must be learning these libraries and tools. Okay, which are for we are using the healthcare and robotic examples. But basically, if you are good in these things, these libraries, then no one can stop you if you are good at all these things. Okay, if you could do one, take an exam, when some requirement comes, immediately you could do on your own, implementing this pipeline. So once again, I'll repeat, there are how many stages? 7 stages are there. The first 7 stages are data collection, data cleaning, feature engineering, model training, evaluation, deployment, and monitoring. So we are in the data cleaning, and data collection can be done using the SQLs, APIs, ROS, and requests. And in healthcare, normally EHR, electronic health data, and lab tests. Okay, and this in a robotics, normally what is LiDAR? Light detection and ranging. Light detection and ranging. Detection and ranging is a method is a sensor which collects the uh, what we call point cloud data, which which is it's a dense of collection of the lidar sensor data, right? So this is used to SLAM algorithm, apply on the SLAM algorithms or a navigation or obstacle avoidance, environmental perception, and object detection and recognition. For all these, LiDAR sensor data is used. Okay, that is basic thing. If you are working on robot, LiDAR, you should know. Okay, what is that? Light detection and range. Okay, this is the basic sensor. Then GPS and camera and other angles or data. You all the data, angles of the arms, angles of the motor, what is the speed, what is the heat, all the sensor data. We can collect using. You should know for this. You should know how we can work using the APIs. How we can get the data using the APIs. How we can make use of the ROS. How we can make use of the request. How can make use of the SQL. Then after collecting the data, we can apply the data cleaning, where cleaning, as I said, there are 5 to 7 stages are there. Missing, working on the missing data, removal or imputation of the missing data. Okay, right? Then duplicates. Okay, how we manage the duplicates, how we manage the inconsistencies, how we manage the outliers, how we can manage the the other category like noisy data, all these things. So for this, you need to learn well the pandas, numpy, and scipy. Then feature engineering. So we'll select the required feature by combining, deleting, updating the data, converting that into our usable format that we call as feature engineering. So that can be done normally in healthcare, BMI and BP features and GPS into the path angles. Then this can be done using the pandas. You can learn, you have to implement, you can implement, these are the basic, there are others also, pandas, sklearn and OpenCV. And model training, like example is heart disease prediction or a cancer prediction. For that, we'll prepare a model, or if it is robotics path planning, or so we can do using this scikit-learn or a TensorFlow or a PyTorch. And evaluation can be done using the uh, accuracy recall and success rate and obstacle avoidance in the robotics. Accuracy recalls, these are the basic metrics which we use in the healthcare examples, which we use the sklearn metrics and matplotlib. And deployment, we will use using the critical deployment. We'll use in cloud or CDS, critical decision systems. We call in the healthcare examples. Deployment we do in the system called critical decision systems. Clinical decision system. This clinical decision system, CDS, or normal nomenclature used in the healthcare models. And on board of the robotics or a cloud, for that we use the Flask or RVS or Docker. Then monitoring is done using the patient safety monitoring and robot error logs. And libraries use our MLflow or Grafana or Kubeflow. So these are the different pipelines. Okay. So which are used pipelines. This is the pipeline, and these are the different libraries and tools which are used in different stages. Okay, so all these things you should be aware of. Okay, now we started discussing the pandas. We completed the Python. Many things are there. Remember, we'll while taking the example, we'll discuss those things. After pandas, we'll discuss NumPy and SciPy. So that will close the data cleaning. Then we'll start sklearn or OpenCV. Already pandas is discussed, and we'll discuss the feature engineering using those. Then while we're doing the model training, we'll scikit-learn as well as the TensorFlow and PyTorch will use in different applications. Okay, like that we'll learn TensorFlow and PyTorch. Then in the metrics, we'll learn what are the different metrics which are used in different applications. Then we'll learn the metrics. So please, these recordings are also will be kept in the E2P Software Academy channel, and you please review whenever you want to review. Okay. Thank you. Like this, we are ending this session. Thank you very much, Divya. Can you stop recording now?
Yes, sir. I'll be stopping, sir.
Okay. So again, tomorrow we'll conduct the workshop. Workshop means the practice sessions, and in the practice sessions,